We're talking about insert last week, and this week we're going to talking about the removal. Okay, so insert a new node into the list. All right, let me share my slides. Okay, same thing. What happened if we try to remove an item from the linked list? Okay, when we said insert a new node in the list, we said that the three different scenarios, right? The node can be inserted at the beginning, to the end, or in the middle of the list. Similarly, when we're talking about remove an item from the linked list, if we think about, there also could be several cases. Okay, if you look at the code, right? Look at the code. This code is basically cover all the different cases for the removal scenarios. The first one, if not self ahead, raise exception list is empty, right? Vic, are you there?
Yes.
Can you tell me what did this two line of code mean?
It's seeing if there's anything in the node.
Okay. So what? We're checking if there's anything in the node, right? So if there's no node at all, what happened? What should we do?
It goes to the next one.
Why do we go to the next one? I said if there's any nodes in the list, what should we do? The function is called remove node, right? And look at parameter. It's parsing a target node data. What does it mean? I give you a value, right? You should help me to remove the node from the list, whoever whose value is equal to the target node data, right? Right? So the first step, I need to check if the node is empty. Think about that, right? If the node is empty, so which means there's no nodes at all. So then there's no reason, right, to continue to do anything, right? So we should raise exception, which means whatever the fact is not meet the expectation, right? You try asking to remove something, but the list is empty, so I don't need to do anything. That's the first case, right? Okay, the second case, if self.head.data, right, equals to target node data. Self.head equals to self.head.next. Okay, so this case is basically means the whatever the target node data is what? Is the first node of the list. Is the first node of the list. That's the second case, right? So what we need to do in this case is reset the head if the target is the first node. Reset the head if the target is the first node. The third case is if the to be moved node is in the middle of the list. Okay, so if you look at this code here, right, we have a for loop, which is basically doing what? Try to find the target node, and then what? To delete the final node from the list. Okay, and if all the three cases has checked, right, but haven't met any cases, then at the end of the function we just raise the exception, which means, hey, you ask me to remove something, but it's not existing in the list at all, so I raise the exception then. Node with data not found. Okay, so that's the whole logic of this function. Now let's look at the details. Reset head if target is first node. How can we understand it? First of all, this if condition, right? If self.head.data equals target node data. What we are doing here? Julian, what's the meaning of this if condition?
If something.
What?
If a certain condition is in place, then the function will.
Certain condition. What I'm asking, what's the condition here? I look at my screen, look at the code. If self.head.data equals to target node data, what is this condition? Julian?
I don't know.
Oh, you cannot know. You just read about understand it, right? What is self.head? What is self.head?
The main node.
What do you mean the main node?
Or
What's the head mean here? Huh? What's the head mean to a list, linked list? It's the first node, right?
Yeah.
The first node of the linked list. Then what's the meaning of self.head data equals to target node data? What is the condition I'm checking here? Huh, Julian? What's the condition I'm checking here?
we're checking if the first node's data is.
If the first node is whatever the node I'm looking for, right? I compare the value.
Yes.
So if the first node is exactly the node value I wanted to remove, what should I do? What should I do? Think about that, right? Basically, I want to remove the first node of the list. Okay, so if you look at this diagram, that is the list. Oh, I know, I find it, right? I found, hey, the head data, the head node or the first node data is exactly equals to the target node data I'm wanting to remove, right? Based on the condition. So what I need to do is I update my head point, right? How can I update my head point? Right? I'm gonna make my head point to my second node. How can I find the second node? Self.head is the first node, then self.head.next is my second node. Okay, so that is this code. Okay, self.head equals to self.head.next, right? Okay, so then it's completed, right? The whole removal completed. You may ask me, hey, what should I do with the data one? Okay, if we update the head, remember when we talk about the linked list, we only care about the head. Okay, because once you find the head, then you're gonna find who the next. Okay, there will be no whatever before the head, right? It was not able to link it, okay, or it's able to refer it by the linked list. Okay, by the linked list. So this is a code how we reset the head in the linked list. Okay, so now let's take a look at the second case. Okay, second case is what happens if the node is in the middle. That is the most complicated case, right? It's similar like we insert the new node into the middle, right? Okay, here, previous node dot equals to self-head. This here is a little bit different is we create a variable called previous node instead of like a node or current node or temp. What's the difference here is, if you think about that, right? When I try to remove a node in the list, what basically you need to do is, hey, make the previous node skip the to be deleted node and point it to the next one, right? So in order to make the changes, I have to remember who is my previous node. Okay, so that's very important. Here is we need to have a variable to hold the previous node, not the current node, but the previous node, because the current node will be deleted, right, by reset the next of my previous node to my next node. Okay, look at the diagram. This is the list. I try to remove data 2. Okay, first I need a loop, find the target node first. Okay, and to be able to hold or remember the previous node, I create another variable called the previous node, right, which hold the previous node. So what I'm doing here is, oh, I found the data 2's previous node is data 1. Once I find this, okay, what I need to do is previous node, which is data 1, the next pointing to what? Data 2 the next, which is data 3. Look at here. The point, how it changed, right? Early, data 1 point to data 2, data 2 point to data 3. Now we wanted to delete data 2. What I need to do is make the next reference change it to data 3 directly. So in this case, my list can have a head and data 1 and data 2, sorry, no data 2, right? Data 1 next pointing to data 3, and then data 3 next pointing to maybe data 4 or pointing to none. There will be no chance to have data 2 in the list anymore. Okay, so if you look at here, right, I'm create a while loop or for loop to loop the list, right? If I not find, I keep looping. Okay? If I found, I just update the next of the previous node to my next, right? To my next. Data 2 next is data 3. That is a code how we can delete an item from the middle of the linked list. Okay? Okay. So yeah. Okay, I think my code here is, let's come back here, right? We have if condition. Okay, to check if the empty list, right? If it is, read exception. We check if the target node is the first node. If it is, we just reset the head to the second. And then if the to be removed node is in the middle, we need to find the previous node of the to be deleted node. And then what? Reset the previous node's the next equals to my the original next of the to be deleted node. Okay, so that's a condition. That's a condition, right? Any more question, right? For those two different cases of removing node. Any more question? Jeffrey, are you following?
Yeah, so there's basically a structure, two heads, and the data. Like there's different commands. This one is to remove an item from a list.
Okay, hopefully just, okay. If you understand logic, I don't think it's difficult to write out the code. Okay, so now let's take a look at it together. So I go back to my code, run this. Okay, everything is good. So now, right, again, I think I don't need this. My code is very clear, right? Class. Again, the remove node class is also belongs to the linked list class. And the remove node function, not class, right? The remove node function is also belongs to linked list class. So what I need to do is here, right? Pay attention to the indentation. Okay. Def remove node. Okay. We need a one parameter, which is target node data. Whatever the data node data I wanted to remove. Okay. So now, remember, what's the first step I need to check? First, I need to check if the node is empty. What's the condition we need to check if the node is empty? If node self the head. Okay. Why this condition can be used? Okay. Now, I first, okay, come back here. If not self the head, why this condition can be used to check if the list is empty? Because if the list is empty, self node equals to what? Jeffrey, if the list is empty, the list dot head equals to what?
Wait, could you say that again?
I said if the list is empty, okay, what is the value of the list dot head?
Okay.
If the list is empty, do we have head?
No.
Okay, if we don't have head, then head equals to what?
Equals to
Head equals to none. Okay, look at here, right? When you initialize the linked list, head equals to none. All right, until you insert a new node, then you set the head to that node. Okay, so because the list is empty, so this is none. Okay, and now we wanted to, if condition, right? We wanted to say that, hey, if the list is empty, I want to do something. So I need to put another not, right? If this is none, then not none becomes true, right? So this condition will become true. Okay, so if true, I said raise exception, hey, the list is empty. This condition, understand it not? Right? Exception. Victor, this condition, did you get that? Victor?
I think so.
You think so, right? Because this is noun. Noun is false, but not noun, not false, become true. Okay? So if true, I raise exception. Okay, so now second step. If it is not empty, I still need to check. Hey, if the to be removed node is my head, that's easy. I just need to check self dot head dot what data equals to, pay attention here, W, right? Target node data. Okay, if that's my head, what do you do? Jeffrey, if I wanted to remove the first node, what should I do?
You have to run the remove function.
What do you mean remove function? I'm writing remove function. I'm asking what's the logic should I put it here? Huh? I just explained, right? If you want to remove your head, okay, which means remove the first node of the list. Okay, what code should we write here? Julian, do you remember? Julian,
Huh?
I look at my screen. Are you following me? I'm
Yeah.
asking you. Okay, now I need to write the logic code of remove head. Okay, I already checked if the list is empty. So now the second case I need to check if the to be removed node is my first node, right? If it is, then what should I do?
Self.head equals self.head.next.
Self.head equals to self.head.next. Jeffrey, what does it mean? Jeffrey?
You would go to the next node.
Okay, it means reset your head to be your current second node. Okay, how can I get the current second node? We know first node the head, right? The head the next is the current second node. You reset the head. That's it. Return. Okay, that's the second case. Third case, we need to find out, right? Third case is remove node in the middle. So to be able to remove the node in the middle, what we need to do first? Victor, what should we do first to be able to remove the node in the middle?
Self.head.
Self.head. We need to loop the list to find the target, right? Just like how we loop the list to find the target when we insert. Same thing. We need to loop the list to find out the target, what we want to remove. But the difference here I explained is to remove the node, we have to remember the previous node. Okay, you have to remember the previous node. So what we're doing here is we need to set the previous. Okay, basically here, I will not using the for loop. Okay, I'm using my own while loop. So previous, I need to create two variable. Okay, node equals to self.head, and what? Previous node equals to make it equals to none. Okay, so I make my node pointing to the. Okay, you know what? To be more accurate, right? So now you understand. Current node and previous node. Okay? Previous node is the previous node of the current node. Okay, now I make my current node pointing to the list head first. Okay, so now I'm gonna do the while. While what? While current node. Okay, I do like that, which means what? Which means I loop every node in the list till the last one. To the last one. Okay. Then we're gonna check. Check what? Check if the current node data equals to target node data, right? Oh, I need to find the exact node I want to remove. Okay. So if I find that, what should I do? What should I do? I need to set my previous node next equals to my next. That's it. So I return. Okay, so remove a node from the list is very simple. Just reset the next of my previous nodes to my next. So it is just skip me, right? So then the whole list will be adjusted. And of course, right, I'm looping the whole list. If I'm not found, what I need to do is current node equals to current node dot what? Next. But before that, you have to using the previous node also. Okay, here we're using two node reference, current node and previous node. Okay, so they will be updated in every loop. Okay, in every loop. When I move to next node, I have to make sure I update these two node variable, right? Two node variable, right? First is previous is none, current is first, and then previous is first, current is moved to the next node. Okay. Okay. So the last case is even you loop the whole list, but you didn't find out the target node data, right? And return from the function. If you come to here, which means what? Which means you are not able to find any node equals to the given value, right? So I can read the exception say node with data not found. So now let's try that. How can we try that? Again, that's a function belongs to a linked list. So if I run again, this is my list. Okay, simple, right? So what I want to is, okay, line break, and let's set delete or remove node 3. So I need a what? Call the function dot remove node, pass in the value, and then print out the new list. Let's see. Ta-da! Right? It's inserted. No, not inserted. It's removed. Right? Node 3 has removed. How is removed? We change the next of node 2 to node 6. To node 6. So when you print out the list, right? Let's print out 2 and 6. Okay, now let's try it again. Okay, what happened if I remove the first node, right? Remove 4. Okay, remove node 4. Now I run this. You see, the node 5 is removed. Now let's do one more testing. Remove node 8. What's gonna happen? Jeffrey, what's the output of this line code?
Remove the node 8.
What's the output? What's the result if I run in this code?
The node. Okay. Something will get removed.
What something you're gonna remove?
Actually, there's no 8 in the nodes, so I think nothing will get removed.
Nothing gonna happen?
Yeah. Nothing's gonna happen.
Okay, if I run this code, there are gonna be exceptions throughout. Remember here, right? We have exception at the end because I looked the whole node, didn't find the target node data. So this exception throughout, and it's clearly say node with data 8 is not found. Okay, that's a checked exception. Okay, so that's great. We covered the operation, how we remove the node from the list. Okay, and this is also I want you guys to do in today's assignment. Any more question? Any more question before we move to the next one? We are all clear about that, right? Very good. So we cover the basic stuff of a linked list, but I also wanted to mention about another enhanced version or advanced version of the linked list called a double linked list. Okay, if you look at this two diagram, okay, Aston, if you look at these two diagrams, can you tell me what is the difference in the double linked list? Compare against the linked list we learned before.
There's a previous pointer.
Okay, so look at the node. How many feeds do we have here in the double linked list node?
Excuse me, can you say that again?
Sorry, I cannot hear you clearly.
Can you say the question again?
My question is, look at the double linked list node, right? How many feeds do we have here? How many feeds in the node right now?
Feeds? What are feeds?
Feeds means property, right?
Oh, one.
No, you didn't get my point. Okay, so we said in the early node, right, we having, okay, we said we have two feeds, right? We have two feeds. Okay, maybe you guys has to be, understand the, or just get used to the property I'm talking about, right? Or terms. We can call that feeds or properties, attributes, right? Basically, that the similar concept in the programming, right? So here, two feeds. So in this node, I have two feeds, right? One is data. Data feed is holding the value of the node. We have a next. Next is the feed holding the reference to my next node. Okay, that's called two feeds. Okay, so come back here. How many feeds do we have here in the double linked list case?
Three.
How many feeds?
Three.
Three. Okay, previous, data, next. Okay, so early we are talking about, it's called single linked list. Single linked list only have one pointer, always point to next. So what's the shortcoming of this kind of like data structure? Which means every time, right, I can only loop the list in one direction, right? In one direction. If I give you that's the reason why the linked list, right, only have head, because head from head you loop the whole list, you can able to find every node in the list. If I give you the last node, are you able to go back to find the previous node? Impossible for the single linked list. Okay, but the double linked list, as you can see, I have two directions. Oh, I can go back to check who is my next, who is my next, who is my next. If I can also go to my previous or back forward to find who is my previous, who is my previous, who is my previous. Okay, so if you look at the whole double linked list, okay, of course we still have a head. Head, okay, the first node is 5, the next is point to 10, 10's next is point to 1, the 1 next point to none. That's normal. But we also need to set up what? The previous node reference pointing to my parent or pointing to my previous. Okay, pointing to my previous. Okay, so now let's quickly create let me see, linked list, right? Let me go here, REPL, Python. Okay, we set a double linked list. Okay, double linked list. So similarly, I'm gonna have class node. Okay, so F double underscore init, right? I have a self.data, okay? And then when I initialize another node, right, I only need to parse in the value for data, right? So self.data equals to data, okay? And then remember here, I have two more feet, right? Next equals to now, okay? Self.what? Previous. That's it. I create a node class for a double linked list. Now, if I want to create double linked list, double linked list, okay, init self.data. Oh, I don't need data, right? Okay, here. Self.add equals to now. Okay. So I create the class for my doubled linked list, right? And you can see I still have one p called head. Now when I create the double linked list, right? That a linked list equals to double linked list. Okay, I create a new one. I create a new double linked list, right? Same thing, I create node. So node 1 equals to node 1, node 2 equals to node 2, node 3 equals to node 3. Okay, now how can I insert those nodes into my double linked list? Okay, yeah. Double linked list dot head. Okay, equals to node 1. Okay, that's not changed, right? But when you set the node, you have to make sure you set the next and previous for you set both, right? Both, right? Node 1 next equals to who? Node 2. Okay, and node 1 dot previous equals to who? Good.
Huh?
What's node 1 dot previous? Here. What value should I set here? Look at here. Node 1 is which node?
The first node.
The first node. Okay, very good. So the previous of the first node is what?
Node 0.
Okay, we don't have 0 here. We've got none. Okay, very good. It should be none. But because the initial value of the node, the previous or next is none, right? So do I need it here? No, I don't need. Okay, I don't need to set the previous for my first node. Understand? Now I want to set the second node. So second node dot. Okay, Victor, can you tell me how can I set the second node? Second node dot node 2 dot next equal to whom?
Node 2.
Node 2 dot
I
next.
mean, node 3.
Node 3, very good. Okay. Then my question is node 2 dot previous set to whom?
Node 2.
Node 2 dot previous.
Then it's node 1.
Node 1, right? So I know who is my next. I also know who is my previous. Okay. So node 3 dot next equals to whom? Victor. Huh? What is node 3 dot next?
node 4 and node 3 dot preview.
No, we don't have node 4. Node 3, the
Oh,
last
then
one.
none.
None.
And
Okay.
node 3 is preview is node 2.
Okay, very good. And actually, I don't need it explicitly to write this because why? Because initial value is none, right? So I don't need that. Okay. So I create a double linked list, right? I create a double linked list. Okay. So again, I cannot say which one is better. The single linked list is better, a double linked list is better. Okay, because though we said double linked list can traverse forward or backward, right? Because you have the previous node. Okay, but you have one more feed, which means you have more space cost. Understand what that means? Because every data is stored in the code, it needs cost. Okay, if you have one more feed created, which means it needs more cost to maintain that. Okay, so that is really depends on what's the actual scenarios you want to choose in the best suitable data structure. Linked list, okay, maybe you just need to forward one direction travel, then you use single list, right? You save the space cost. But sometimes you do need a two direction traverse, right? And then you have to use double linked list, right? It can help you to faster travels. Okay. So that's a double linked list. Okay, I just give you some, basic introductions. I will not go too deep. Okay. Another thing is called a circular linked list. Have you ever think about that? It's a linked list, a list of nodes. Node 1 point to node 2, node 4 point to node 3, node 3 point to node 4. Is it possible to point them back to the first node of the list? Possible. Look at this. It's headed 5 to 10, 10 to 20, 20 to 1. Oh, the next of the node 1 pointing to the head. That's called a circular linked list. It's form a circle. Okay, the last node point back to the heading center. I mean, this kind of case is usually happened or like in one question. If I give you a linked list, I give you one node. Okay, no, I give you a linked list, right? I give you the head of the linked list. Can you tell me if this linked list is a circular linked list or not circular? What's the difference? If it's a normal linked list, I can loop from the first to the end, right? But if you think about if this linked list is a circular, the while loop I'm doing to checking if the next is none, it will not working. It means the while loop is infinite. Because why? Because every node has a next. Every node has a next. Right? Every node has the next. So that's a difference between a single linked list and a circular linked list. Okay? Okay, so that is just another type of the linked list I want to cover here. And there's other topic called 2 points, right? I give you a linked list to find out the middle node in the linked list. How can I find the middle node? If I give you a list, a normal list, right, or array, how can I find the middle? It's easy because why? Because I know the total size of the array, right? I know what is the middle index, so I can get the middle value of the middle index, but not the linked list, because linked list is dynamic size. You cannot know the size of the linked list at the beginning. Okay, and also same thing, right? Find the last third node in the linked list. How can I do that? I don't know the size. How can I know the last node, third node? Detect the circle in a linked list. A linked list can have a circle. Or find a joint node of two linked lists. Okay, two linked lists. Okay, 1, 2, 3, 2, 2, 4, right? They can have a joint at one of a node. Okay, so that is all the different derived questions about the linked list. Okay, so I just have a quick, heads up about those topics here, and we probably can, go to the details in the future. Okay, so we still have a few more minutes. Actually, I want to save the time to start the next topic. Okay, before we start the next topic, right? Do we have more questions about the linked list? Jeffrey, are we clear?
Yeah, I think we're good.
Are you able to create the remove node function?
I think so, yeah.
Okay, are you able to create double linked list? Double linked list. Okay, have a
Double
2
link.
point. Okay, I hope you can, I mean, whatever I'm asking you to is covered in my video. Okay, make sure you go back to my video, and I hope you can complete that in assignment. Okay, guys, so I want to move to the next topic. It's called a stack. So we covered the array, we covered the linked list. Now we're going to talk about the third basic data structure. It's called a stack. Okay, what does it mean stack? The stack is something like a pile. You put the stuff one above another one, right? That is like the picture you can imagine how the stack look like, right? If I give you the stack 0, 1, 2, 3, 4, this is similar to index, what we learned before, right? But if you look at the value, I have a 5 at the bottom, and then I put a 6 on top, 9 on top, 2 on the top, right? And then I have an empty space, right? And I also have a top reference, just like a head, right? I have a top reference here pointing to the toppest number, the toppest data of the whole stack. Okay, so that is how stack could look like. Okay, that is also a linear data structure. Okay, because it's a chain or it's a linear. Okay, that's just data structure. And of course, right, there's other way is, oh, this is array, right? Look at array. When we talking about array, I mean, we prefer to, make it like from left to right, right? And have a total of 5 items here with different index here. But when we talk about stack, right, I always prefer to imagine it as a, as a vertical data structure, look like this. And every time I want to add a new values, I just put on top, stack it up, right? That's called stack. Okay, and this is a linked list, right? We learned. So array, linked list. Now we want to talk about stack. Okay, stack. When we're talking about stack, okay, we always talking about LIFO, FILO. What does it mean? LIFO, last in, first out. FILO, first in, last out. Okay, how to understand that? Look at here. I have a stack which is empty at the beginning. Now, first action I did is push A. So I put an A into my stack. Now, push B. I push B into my stack, which is on the top of the A. Push C into the stack. Push C into the stack. The C will be on top of B. Push D on top of C. Okay? The stack can have two different operations. Push item into the stack, pop item out of the stack. But very important, when we pop item, we only can pop the topmost item. Okay? You only can pop the topmost item. That's called first in, last out. Right? Or we call last in, first out. Why I say last in, first out? Look at here. Push D, D on the top. But when I say pop, I can only pop D. Right? Whoever last in when to the pop will be the first out. That's called last in, first out. Then think about it. First in, who is A, he is at the bottom of the whole stack. If I wanted to pop it up, so which means what? I have to pop all the items above him. Pop D, pop C, pop B, and pop A. That's called first in, last out. Any question for this concept? Victor, did you get that?
I think so.
Okay. Last in, first out. First in, last out. That's the character, or that's the most specialist of stack. When people talking about stack, okay, at least in programming words, okay, stack means last in, first out, first in, last out. Okay, Julie, are you following?
Yes.
Okay, so now let's take a look at this firstly. Again, right? So that is all the function we usually needed for a stack. Okay, empty, which is a function to return if the stack is empty. Okay, return whether the stack is empty. Okay, so Jeffrey, what do you think the type of the result of this empty function? Right, when I say empty function, there must be a result returned from the function, right? What's the type of the result do you think should be?
True or false?
Correct. Very good, right? Because I said if it's empty or not empty, true or false. So which means the return value of the empty function must be true or false. It's a Boolean. Very good. Second function called size. Okay, I have a stack. You push in, push in, push in, push in. I want to know how many items. That's called a size, right? Return the size of the stack. The third function called top, right? Return the reference to the topmost element of the stack. Okay, we know a stack can have multiple items in the stack, right? But I want to know the topmost one. Because sometimes when I'm using the stack, I need to check, hey, do I need to pop the first one? Oh, keep pushing, keep pushing, keep pushing, new items. So there is a way to get the top item of the stack. Okay, that's the top function. And of course, we have push function. You can see it takes a value, which means push the new value. Okay, add the element value at the top of the stack, and then we have pop. Delete the topmost element of stack. Okay, I keep keep pop until the stack is empty. Okay, so if you look at this diagram, stack is empty, push the value 1, keep pushing, value 2, value 3. Okay, that is the state of the stack after several different operations. Okay, I need you to tell me what is the operation we could happen here. Okay, could happen here. Okay, the first one, stack is empty. Okay, you need to tell me which function I'm going to call. Okay, Victor, the second stack has value 1. So what function probably called? Victor?
Empty.
No, I said it. This stack is empty. Now I go to the second stack, right? I have a value 1 here. So what function has been called? Victor. Victor?
Yeah.
Did you get my question?
No.
Okay. I have a 5 stack here, right? You see that? Victor?
Yes.
I have 5 stack here. The first stack is what? It's empty or not?
It's empty.
Okay, it's empty. Very good. So the second stack, what's the difference from the first one?
The first one?
Yeah. The second stack, what's the difference from the first one?
Oh, the second one is the empty.
The second one has a value, right? Value 1. Am I right?
Yes.
So which function has been called?
Second one?
From the first, that's the state of the stack, right? Stack has been changed. Okay, so I'm asking you from the first stack to the second stack, what is the function called? This function. Victor.
我踩我，说对不起，不说对不起，9:15。
Victor?
I think it's the first one because it's empty.
Yeah, first is empty, correct. What about second? Second, I have one more value here. Huh?
It has a value.
I have a value, yeah. I have a value pushed inside of the stack, right? So what is the function has been called?
Push value?
Okay, push value, very good, right? I wanted to add a new item into my stack, so I'm gonna call push value, right? And the value is the value we want to push into that, value 1, right? Very good. What about the third one? Victor, third one. So from the first to the second, I push value 1. What about from the second to the third?
Push value 3.
Push value, where is value 3? Value 2. Right? Third one is push value 3. Okay? Push value 3. Now the challenging one, the fourth stack. Oh, it become 3 and 4. There's no 2. Become 3 and 4. So from the third stack to the fourth stack, what exactly operations has been applied or has been executed? Aston, you get my question?
Yeah.
From the third stack to the fourth stack, what happened?
You first pop value 2.
Pop value. You don't need to say pop value 2 because it's always pop the toppest one. Okay, just say pop. Right? Pop, which means remove the toppest one, which is value 2. Okay, then
Push value 3 and 4.
okay, push value 3 first. Why? Because 3 is go to first, then it's and then push 4. So 3 button 4 is on the top of 3. Very good. Okay. So the last stack, value 1 only. Julian, what happened from the last second to the last stack? What's the operation happens?
Pop.
Okay. I have 4, 3, 1. I do pop. And then, okay, I do pop, which means value 4 removed, right?
Yeah.
And then, what I still have here? 3 and 1, right?
Yeah.
Am I right? Pop is only pop the toppest one. The toppest one right now is 4, right? So do 1 pop, you delete value 4. Then you need to go to the last one. What do you do? Julian?
You do pop 2 times.
Okay, very good. Pop 2 times. Clear? So let's do it again, okay? First stack is empty. Okay? Then push value 1. Push value 2. Pop. Push value 3. Push value 4. Pop. Pop. That is how I have only value 1 in my stack. That's it. Okay? Any more question? Any question about this content? No matter it's linked list or the stack? Okay, so if no more question, I think that's it. So today's assignment is still about the linked list. Okay, one way is add the remove node function. Okay, second assignment will be create a double linked list. Okay, stack. I will not give assignment of stack this week because I gonna cover more. Okay, next week. Okay, that's it. If no more question, thank you everyone, and have a good night.
Good evening.
Thank you.
Good night.